from a set S 1, 2, 3, 4, we choose 2 elements and make subsets like this. Test, build subsets. This set S has 4 elements and we select 2 elements. Then we make subsets. Stream and there from a set S 1, 2, 3, 4, 5 elements, we choose 2 elements and make subsets. Test, build subsets 5, 2. In command prompt, we build CLS and run. So from set S 1, 2, 3, 4, we select 2 elements 1, 2, 1, 3, 1, 4, and 2, 3, 2, 4, 3, 4. So total 6 subsets. Again, from set S with 1, 2, 3, 4, 5, we choose 2 elements and make subsets. There are total 10 subsets. In this episode, we will learn how to turn our mathematics to our algorithm. Hi everyone, my name is Thomas Kim. Today is July 4th, 2019. This is my 45th episode about the future of C++ programming, C++2 standard. In this episode, we will learn how to convert mathematical ideas into a working algorithm. If you are a student at college, don't neglect to study mathematics. Mathematics gives you wings that enables you outstand among your fellow students. After graduation from college, you can take full advantage of your mathematics at your workplace of any kind. Mathematics is hard and difficult to learn for anyone, but still it can be a great tool for your career of any field. As a student, make it a habit to turn what you learned at math class into a working algorithm. Our strategy: first off, understand your problem crystal clear. Second, use simplest approach to solve the problem. In my case, I usually use recursion 9 out of 10 cases. Once I implement the algorithm, then I turn the algorithm based on recursion to a loop. This is my usual programming style. This subset construction algorithm is used a lot in real working application development. we'll be using Pascal triangle. If you do not understand what is Pascal triangle, please watch this video. I explained the concept of Pascal triangle in this episode. We are going to choose R elements from a set S with N elements. Suppose S has 4 elements, 1, 2, 3, 4. And from set S, we will choose 2 elements and build subsets. Since S has 4 elements, N is 4, and we are going to choose 2 elements, R is 2. So the total number of subsets are given by 4C2. This number happens to be 6. N is 4, R is 2. Pascal triangle says that NCR equals N minus 1 CR minus 1 plus N minus 1 CR. Using this formula, 4C2 is given 3C1 plus 3C2. From set S, we create S prime like this. We remove the first element of set S. The first element is stashed here, and we collect remainders 2, 3, 4. Using S prime, we build this part and we build this part. We will start with this group, first group. From set S prime, we select one element like this. First, we select 2. Then we select another element 3. Then we select another element 4. So we completed the first group. We completed the first group. This is first group. Then we build the second group, 3C2. From this set again, we select 2 elements from this set, S prime, 2, 3. 2, 3. From S prime, we select 2 elements, 2, 4. 2, 4. From S prime, we select 2 elements, then 3, 4. 3, 4. Please note that we originally select 2 elements. This group has only 1 element, so we put the stashed element to this group like this. 1, 1, 1. This group belongs to 3C1 and this group belongs to 3C2. This group comes from this part and this group comes from this part. Okay, so this number is 3C1. This number is boundary between two groups. Now we label subsets like this: 0, 1, 2, 3, 4, 5. And we label this index 0, 1, 2, 3, 4, 5 m's. Okay, so m's is 0. It becomes the first state 1, 2. m's is 1. It becomes 1, 3. When m's is 2, it becomes 1, 4. When m's is 3, the subset becomes 2, 3. When m's is 4, the subset becomes 2, 4. When the m's is 5, the subset becomes 3, 4. Okay? Now we will turn this into algorithm. In case of set S, n is 4, the number of elements. We are selecting 2 elements and build subsets. So R is 2. Okay? And in case of this set, n is 5. Because set S has 5 elements, we are also selecting 2 elements and build subsets. So R is 2. The m's is from 0 to 5. Okay? In this case, m's is from 0 to 9. Now let's think about the range of m's. In this case, m's can be greater than or equal to 0, less than 4C2, which is 6. In this case, m's is greater than 0 or equal to and less than 5C2, which happens to be 10. Okay? Now let's think about this demarcation. And also here, this demarcation. We split into 2 groups. In this case, 4C2 equals 3C1 plus 3C2. This number is 3. 3C1 is 3. Okay? In this case, 5C2 equals 4C1 plus 4C2. This equation is Pascal's triangle. This equation is Pascal's triangle. So this number for C1 happens to be 4, divides the subsets into two groups. This part is less than 4. This part, this group, is greater than or equal to 4. In this case, this group is less than 3. This group is greater than or equal to 3. So this number determines the boundary between two groups, of subsets. Now we will turn this into algorithm. On the CPP extension folder, select Tutorials folder, click this button, 045 subsets CPP, hit enter, Ctrl B, include talk play fun, output HPP, include talk play fun, NCR, NPR, HPP, void build subset, void test subsets size T and size T R, int main. We will call this function for2. Here talk play fun SS stream. If you see this squiggle, Ctrl Shift P, edit configuration JSON, CPP extension dir, put this line of code, then go to File, Save All, then close it. Auto, NL, talk play fun, NL. A single line carries return and flush to console. Auto, NL, talk play fun, NL. 2 carries return and flush to console. I see 1 carries return. Now here we will define using element T, size T, using set T, std, dq, element T. We will take set TS, set TR, R is result set, it should be reference, size TR, size T m's. Okay. Now here set ts, we reserve memory n, allocate memory for n elements. std iota s begin. We initialize s and we will be using lambda like this, and size t, it should be mutable. Then return plus plus n. We initialize the set s. Now we display original set stream. The set s and L. Now we will build this function first. Start your command prompt. You should be in CPP extension tutorial folder. dir 045 star, hit enter. You should see this file cl ehsc std c++17 045 subsets cpp fe aexe, hit enter. Let's see. Sorry, I made a mistake here. I will copy this, paste. I will disable it. I have to change it to generate. Okay, I have to fix like this. Now let's build once again. Okay, we generated a set S with 1, 2, 3, 4. Now here we calculate the range of m's, or max m's, talk play fun, ncr mpr, ncr s, it should be n and r like this. So for size t I equals 0, I say m's equals to 0, m's less than max m's plus plus m's. Okay, this is total number of subsets. We create set tr and we can reserve. No, we can't reserve. I will just do this. Then we call this function build subsets. We pass s, then r, this set r, then r, then m's. After this, we display stream m's, then we display R. R is the subset. And like this, we are calling build subset. Here, if R is 0, we simply return. Else if R size equals to R, then we copy all elements. This means, for example, S has 2 elements, 1, 2, and if R is 2, then we append elements of S to R like this. R insert R end. We insert elements of S to R like this. std make move iterator S begin std make move iterator S end. Then we return. We have nothing to do. Now in this case, we compute the boundary NCR n-1 CR-1 plus n-1 CR or n-1 CR-1. This is the boundary. Talk play fun. NCR, NPR, NCR. Please note that n-1 is R size minus 1. S size minus 1. Okay? And V R minus 1. This forms the boundary. Please note that we are calculating this part. This is Pascal's triangle. This forms the boundary. So let's keep going. If m's less than n-1 C R-1, else we are in this case, in the first case, first group. If less than C minus 3C1, if less than this number, then we first remove the first element. We move the first element of S to set R. In this case, R is the result set. Push back S front. Copy the first element of S to R. Then we remove the first element S, pop front. Remove the first element of S. Okay? In this case, this is R is result set. Okay? R is the subset we are going to build. Since we inserted one element from set S to R and we removed the first element of R, we have to decrease R. Since we determined the first element of the subset R. We decrement R. Then we call this function recursively, like this. S, please note that one element is popped up here. Then R is removed from here. Then M's. Now in this case belongs to this part, the second group. Okay? In case of second group, we remove the first element, but we do not add to R. We remove the first element of S pop front, but we do not add the first element of S to R. Okay? Now we have to decrement M. So in this case, for example, if MC is 3, this number, we delete, we subtract 3, this boundary. We subtract this boundary, we make it to 0. Okay? Then we subtract this number. And we call this function once again recursively. S R M's. Please note that in this case we have to minus 1 because we added one element to result set S, but we do not decrement M's. In this case, we decrement M's with NCR N1 CR1 with this value, but we do not modify the value of R because we still have to select R elements. In this case, in the second group, we removed the first element from S, but we still have to select two elements. We still have to select two elements, okay? We select two elements. In this case, we do not modify R. In the second group, this is second group, okay? This is first group. For the first group, this is for the second group. For the second group. In case of second group, we do not modify the value of R. We only modify the M's, like this. In case of first group, since we added one element to R, we have to decrement R. So everything is done. Now let's build and run. We build once again. CLS. Now it built successfully. 0, 2, 1, 3, 1, 4, total 6 subsets. Now if we try another one, stream, and there, now we can test like this. Test subsets 5, 3. For example, we build once again. I copy this function name, pasted it here. We build again CLS. So in this case, from the set with 5 elements, we are selecting 3 elements and make subsets. Or if we want to, for example, 8 elements from a set with 8 elements, we are selecting 4. It will be huge. CLS. Wow. Okay. Now it has 8 elements. From a set with 8 elements, we are selecting 4 elements and make subsets. Total 70. This is 70 because it starts with 0. 70 subsets. Please understand that our current implementation of build subset, we are using recursion heavily, and using recursion is inefficient. We will optimize build subset in some future episode. If you can implement subset construction, you can implement most algorithms in the theory of automata, even theory of computation. You can implement most algorithms in the theory of automata. This algorithm might look a little bit challenging for you, but I highly recommend you completely understand this algorithm. In my previous episode, A Little Math Won't Hurt You, Pascal Triangle, I explained the importance of Pascal Triangle. I used Pascal Triangle to build a subset. I will upload complete source code to my website, extensiontalkplatform.com website. By the time you watch this video, you can click this button to download complete source code. And also, if you want to build my source code, you have to watch this video and install latest version of Microsoft Visual Studio 2019. After installing, you also probably need to install GNU G++ and Clang by watching this video. Then you also have to make some system environment variables by watching this video. If you leave questions and comments, I will try to answer as soon as possible. Please subscribe to my YouTube channel. Thank you for watching.